Hello class, today we're going to be getting into implicit differentiation. So it's a new method of differentiation. Now we use implicit differentiation when we have a function that is not described in terms of y. So everything up to this point that we've been doing as far as finding the derivative of, it has always been something that looked like, let's see what color am I going to use, I'll use green, always looks something like y equals 2x squared plus 3x minus 4. Something like this, where we have it y being defined, where it says y equals something, right? And we can easily take the derivative every time we see an x, right? Well, what if we have a function where it's not described in terms of y, where y is just somewhere in the mix of everything? Well, that's when we need to use implicit differentiation. And it kind of goes along with the chain rule. You'll see what I mean when we get there. So the steps of implicit differentiation, it's just not that bad. There's only two of them. The first one is we need to differentiate both sides with respect to x. So differentiate just as we were doing, like up here, but with respect to x. The difference, though, is when we differentiate a y term, any term with a y, we need to multiply by dy dx, and that's where the chain rule kind of comes in, because yeah. And then second step, solve for dy dx. But let's talk about why for a minute we have to multiply a y term by dy dx. So let's take something like this, just y squared. Well, if we are differentiating with respect to x, think y is something else. Y could equal 3x plus 2, can't it? But we don't know what y equals right now. So when we differentiate, we need to differentiate the y. So it would be 2y, right? We just use the power rule. And then we need to write dy dx, because we need to differentiate the inside. This is differentiating the outside, right? If this were the case. And then we just need to write this, dy dx, to show that we are taking the derivative of whatever that y is, but we don't necessarily know what y is. Well, we do. We do. We just have to solve for it, and it's a lot of extra work. So let's go through these steps together and differentiate this this equation right here. So this is the equation of a circle whose radius is 4. Let's see. So okay, x squared plus y squared equals 16. Okay. So let's first differentiate both sides with respect to x. So let's see what color. I'll use this. Okay. So we're going to differentiate x squared, which becomes 2x. And then we need to differentiate, I don't like that. That's a little too light. I'll just use green. 2x. And now we need to differentiate y squared. Well, that's going to be plus 2y, but because it's a y, we need to differentiate that inside, so to speak. So we're going to have dy dx, and then equals, and then 16 was, well, just a constant, so the derivative of any constant is just 0. So here we have 2x plus 2y times dy over dx. Equals 0. So now we need to solve for dy dx. So let's get all of the terms that don't have dy dx onto one side, which means we're going to subtract this 2x from both sides. So that will cancel. And now we have 2y times dy dx equals negative 2x. Well, we're almost there. We just need to now get rid of this 2y. We need to move this 2y over. It's being multiplied to dy dx. So let's divide both sides by 2y. So this will cancel. And we have dy dx is equal to, let's see, these 2's will cancel, so it's just really going to be negative x over y. And there we have it. We have implicitly differentiated this equation. Let's go on to another one. Where am I? Ah, there we go. Okay. Now let's take a look at something like cosine of x equals x squared times y plus y equals 12x. Excuse me. So now, again, let's differentiate in terms of x, or with respect to x, rather. So let's see. Cosine of x. There's no y. The derivative of cosine of x is just going to be negative sine of x. And then notice here we have x squared y. Here we're actually going to have to use the product rule for this term right here. So remember, hopefully we're good at the product rule by now. So plus, let's see, I'm going to take the derivative of the first term. So x squared is going to be 2x times y. Now, I didn't take the derivative of y, so I don't need to do dy dx just yet. Plus, let's see, plus, now the first one, which is just x squared, times the derivative of the second one, which is the derivative of y is just going to be 1, but with respect to x, it's going to be 1 dy dx, or just dy dx. And then we need to do this term, so plus y. So it's going to be plus, well, this is going to be dy dx, because the derivative would just be 1, and then we need to write the dy dx since this is a y term, and then equals the derivative of 12x is just 12. So now let's get rid of these parentheses and kind of see what's going on here. So let's see, there's a positive, so we don't really need to distribute anything, so I'm just going to rewrite it. So negative sine of x plus 2xy plus x squared dy dx plus dy dx equals 12. So now we need to solve for dy dx. So let's start with getting all of the terms that don't have dy dx onto the other side where that 12 is. So it looks like to me we need to add sine of x to both sides. And we need to subtract 2xy. Okay. So let's see. Oh, my brain just exploded. So these go away. And so now we're left with x squared dy dx plus dy dx equals 12 plus sine x minus 2xy. And now, this is the trick. When we have multiple terms that have dy dx, and we're solving for dy dx, we're going to want to factor that dy dx out. So let's see. Dy dx is the common factor that I'm concerned about. So I'm going to pull that out. And now we're essentially dividing both of these by dy dx. So x squared dy dx divided by dy dx is just going to be x squared. Dy dx divided by dy dx is just going to be plus 1 equals 12 plus sine x minus 2xy. And then now we can, as you can see, we can go ahead and divide both sides by x squared plus 1. And this will cancel. So we have dy dx is equal to 12 plus sine x minus 2xy all over x squared plus 1. And there you have it. That's it. All right. Let's go on to the last one. So this one it is defined, or y is alone, but notice that y is defined by itself. So again, we'll have to use implicit differentiation. So let's go ahead and find the derivative of these terms. So the derivative of 3x is just 3. Plus, and then here again, we're going to have to use the product rule. I'm going to split it into this. I'm going to split it into 2x and y squared. So let's get our parentheses out. Whenever you do the product rule, always use parentheses because sometimes we might need to distribute something up here. Or if it were a negative, we'd have to distribute. All right, so let's see. We have 2x times the derivative. Oh, I guess I could have taken that first. Oh, well, it doesn't really matter. So 2x times the derivative of the second one, which is going to be 2y times, but since we took the derivative of y, we need dy dx plus the derivative of the first one, which would just be 2, times the second one, y squared. And again, we didn't take the derivative of this y this time, so we don't need to put dy dx, equals, and y is just going to become dy dx. Oh, I forgot my end of my parentheses right there. Okay. So now let's get rid of the parentheses. We don't need to do anything here. I'm going to simplify this part. It's going to be 3 plus, I'm going to call this 4xy, if that's okay. I'm just multiplying them together. dy dx plus 2y squared equals dy dx. So now we want to get all of our dy dx terms onto one side and all of our other terms onto the other side. So this time I'm actually going to move excuse me, this 4xy dy dx over to over here so that they're together, so that we can then factor. Oh, sorry, dy dx minus 4xy dy dx. And we're left with 3. Let's see, 3 plus 2y squared equals dy dx minus 4xy dy dx. So now on the right side, we can factor out that dy dx, which is going to give us dy dx times and we're dividing it out, so dy dx divided by dy dx is just 1. Negative 4xy dy dx divided by dy dx is just negative 4xy. And we didn't do anything with the left side here. 2y squared. And now we can go ahead and divide both sides by 1 minus 4xy. Oh, sorry, x, 4xy. I don't know what I was doing there. All right. And so what we're left with here is dy dx is equal to 3 plus 2y squared, 1 minus 4xy. And there we have it. Let's go over one more example here while I have your attention. All right. So now we have 4y squared plus 3x minus 2y equals x. And let's see, we're going to want to take the derivative of each term with respect to x. So this first one, see, take the derivative is going to be of the outside is going to be 8y times the derivative of this y, which is just going to be dy dx, plus 3x is going to turn into 3, minus 2y, that's just going to be minus 2 dy dx, because the y goes away and then we need to take the derivative of the inside, equals 1. The derivative of x in respect to x is just 1. So now let's move all of our terms that don't have a dy dx onto the right side. So I'm going to subtract 3 from both sides. That's our only term here. And we have 8y dy dx minus 2 dy dx is equal to, let's see, 1 minus 3 is going to be negative 2. All right. Now let's factor out that dy dx. That's going to give us 8y minus 2 on the inside. Right, we're just getting rid of that dy dx equals negative 2. And then divide both sides by 8y minus 2. So what we have left is dy dx is equal to negative 2 over 8y minus 2. And that is explicit differentiation. So I have this video. There's also another video that I really liked. I was watching earlier. I actually kind of modeled the first part of my notes over it. I will link that as well for y'all if I don't forget, so you can watch that as well. But that's all I have for y'all today. So that's implicit differentiation. Let me know if you have questions, and have a good day.